Welcome to our Spatial Learning video series, where we'll use the power of spatial computing technology to take learning to the next level. Wherever you are, we're excited to go beyond your TV, textbook, or computer screen and blend learning experiences into our physical world together.
My name is Alex, and I'm going to be your spatial learning guide for this adventure and many others that we'll do together over the next several weeks and months. As you guys are at home and learning in very different ways than we're used to, not necessarily in a classroom, but maybe in your living room or your bedroom, we're still going to be able to have really exciting learning experiences together. These brought to you by the power of spatial computing, with this technology for Magic Leap and really exciting applications on top of it. The idea here is that we can learn outside of a 2D screen, like a computer or a textbook or a TV, and actually bring three-dimensional learning experiences all around us into physical space. We can do this for anatomy, for archaeology, for history, and also for chemistry, which is what we're going to do today. So this experience is brought to us by a great application developer called Xennial Digital that's built an application here called Molecule Builder. And what we're going to do together is learn about how atoms come together to create molecules, and specifically the bonding process that makes that happen. So what we normally do is we take a look at all of these atoms or periodic elements on a table like this, which is flat. And it's got their numbers, it's got their names, hydrogen over here, carbon, nitrogen, oxygen, sulfur, chlorine, and many others all around it. But we all know that these elements don't exist on a flat screen. Rather, in real life, they're all around us, sometimes on their own, other times all together in different chemical compounds or molecules. Now, how do they come together? Let's learn about it. But not on a screen like this. Let's actually dive in three-dimensionally for a spatial learning experience. To do that, we're going to take a look at our spatial learning portal here. And we've got a number of different molecules that we can create together. The first one we're going to work on is H2S, hydrogen sulfide. We'll then go down to NH3, which is known as ammonia. And then we'll jump down over here to carbon tetrachloride, CCl4. And these are just a few of many, many, many molecules that exist naturally in our physical world. Let's start with H2S, or hydrogen sulfide. We have two hydrogen atoms, which are the blue ones out here, and we have a sulfur atom. Now, there are many differences between these elements that we'll learn about, but the big one that we'll focus here is on the electrons that exist on their valence shell, which are represented by those white dots on the outer rim. We'll notice that hydrogen only has one, whereas sulfur has 6. So how do they come together to go from 3 distinct atoms to a chemical compound or molecule? Well, they bond together through the covalent bonding process. The way that this happens is that we go and bring together the electrons from the sulfur atom and the hydrogen atom, and in doing so, that creates this bond over here. And we can repeat the process right over here, and sure enough, that gives us this H2S molecule, hydrogen sulfide, which of course exists in three-dimensional space, right? We can get nice and close to it. We can look at it from different angles, just like this exists at a much, much, much more microscopic scale in our physical environment. Now, before we finish, let's take a look on our big board over here at the structure. And let's do a quick check. Sure enough, a perfect, stable molecule. Let's move on to our next one. NH3, ammonia. Now, we're going to see something very similar, the hydrogen atoms. Instead of 2, there are 3, and we can just pull them out exactly as we did before. The big difference, of course, is that instead of a sulfur atom, we've got nitrogen. And we'll notice as we bring him out that the difference here, for our purposes, is that we've got 5 electrons on the valence shell instead of 6. But the process to bring these atoms together as a molecule is exactly the same. We'll take the electron and bring it together, and we'll do the same thing over here. And let's do one more. And there we go. We've got nitrogen bonded with 3 hydrogen atoms to create a very different molecule called ammonia. Different properties, different experience, but many of the same elements and the same process to bond them together. We'll check our big board again, and we can bring this down slightly so we can see the full thing. And then let's do a check. Sure enough, another perfect stable molecule. Now let's finish with the most complex one that we'll see today, CCl4, carbon tetrachloride. We've got 5 atoms to put together now instead of 4 or 3, but again, the process is exactly the same. We'll pull out our carbon atom, which we see has 4 electrons in the valence shell, and then we'll bring out the chlorines, which each have the most on their valence shell that we've seen so far, which is 7. Let's bring them all together like we've done before. There's our first bond, our second bond, our third bond, and our fourth bond. A couple of things to consider here before we wrap up is that all of these chlorine atoms have many additional electrons that are unbonded right now. What does that mean? That we can actually expand this molecule to have additional bonds over to additional atoms if we wanted. Right now, we're only looking at this particular structure, which we'll do a quick check on right now. And indeed, it's another perfect stable molecule, but we can remember that this can be expanded to create many of the much more complex molecular structures that exist naturally in our physical world. The last thing I'll mention is that just like these bonds can be formed, so too can they be broken. And when this break happens, there's a release of energy and a lot more that can happen, which we can learn about at a later point in time. But the important thing to consider here is all of this exists naturally in our physical environment. The bonding, the breaking, the combinations of these different atoms to create molecules that exist all around us, not in a screen off to the side like here, the periodic table of elements, but all around us in physical space. That's all for now. For our first spatial learning experience. Again, my name is Alex, and excited to see you guys again very soon.